Now let's design a linear regression model on a data set that contains student scores. So this is the data set right here. This is my CSV file. It contains hours and scores. Hours refers to the how many hours the student studied, and score refers to what is the score they obtained out of 100. So in this particular instance right here, your student studied for 5.1 hours. His score is 47. So these types of data it contains. So in this case, you're given a CSV file that contains student study hours and their scores. So your task is to design a model that will make a prediction based on the hours that is fed into. So if you give an hour, let's say 9.5 hours, the model is going to make a prediction on how many or what his score is going to be based on the number of hours he studied. So the steps I'll be following would be this: collecting the data, then I'm going to split my data into training and testing, and I'm going to feed the training data to the model. And this is going to train the model. After that, I'm going to evaluate the model on the test data set. So let's import my pandas as pandy. So run this. So let's collect the data. In this case, I'm just reading my CSV file. This is my CSV file right here. So let's run this. And I'm also printing my data frame right here. I'm giving a print command and it prints out my data frame. And as you can see, there are total 34 records. So it starts with index 0 and ends at index 33. Okay, I want to do a scatter plot. I want to see how this X and Y in hours and scores are plotted. So you can see that this is how it looks like, your hours, and this is your score. So as the number of hours a student studies, his score actually goes up. So that's okay. That's pretty fair assessment. All right. And now I'm going to split my data into training and testing. So the first thing I do, I separate my data into feature X and response Y. So in this case, I'm extracting all my feature. In this case, there's only one column, which is hours. That's my feature. And my response in this case is scores. So it actually separates my data into X and Y. Step two, then I perform training and testing and splitting. So in this case, all I'm doing is I'm feeding my X and Y to my this function train test split. And what this function does is going to take X and Y and it's going to spit out a training set and a testing set. And it's also it also has the option to specify like how much of your data do you want it to be assigned to your testing. In this case, I'm saying give 20% of my data to assign 20% of my data for the testing. So it creates that. Now I want to look at my shape. I want to see the size of my training and testing data. And you can see that it assigned 27 rows or 27 data points to the training, and it assigns 7 to the testing. And now we're going to be doing modeling and training. So in this case, I'm using linear regression, simple model. And this is going to be predicting a numerical value. So this is my linear regression model, and I'm training my model. So the way you train it is you call this inbuilt method called fit. And in the fit, you supply your training data and your training response variable in this case. So let's run this cell, and that got trained pretty quick. In this case, the data is not very big. That's why it got trained this fast. In real life, your data would be very big, and this may take anywhere between few minutes to even days. Okay, so my model is trained. Now let's make a prediction. So let's say there's a student, he studied for 9.5 hours. And I want to know what his score is going to be if he studied for 9.5 hours. So I'm feeding the data to the model. There's an inbuilt method called predict. I'm feeding this data new data, which is this right here. And then it's going to give me the score. So when I run this, it tells me the score is going to be 98. So somebody who studied for 9.5 hours, his score is 98. Let's just try to see if it makes sense. So if you go back over here, look at this. This is 9 and 9.5 would be so 98. Okay, somewhere over here. That seems kind of reasonable. The answer is going to be somewhere over here. What if I put some other number? So let's put this number to maybe 5. Let's say there's somebody who studies for 5 hours. What is his score going to be? Well, it's saying 53. Let's just go verify. So 5 hours would be somewhere over here, and 53 is somewhere over here. So yeah, that kind of makes sense. You see, it's kind of fitting with the data. It does fit in the data line. All right, so our model is making sense. Okay, it's making a correct prediction. Now, I want to know my model. I want to know the performance of my model, like how good it is doing on the test data set. So, step one, I make a prediction on my test set right here. So, it's going to make a prediction on my test data set. So, let's run that, and it makes this prediction right here. So, the first value is 92, the second is 77, and so on and so forth. Let's find the corresponding X test over here. So, in this case, you can print out the actual test data set. Oops, sorry, just print out your X. So in this case, if I type print X test, I'm going to run this, that's going to give me the X test. So the guy who studies for 8.9 hours, his score, the model predicting is 92. And the guy who studies for 7.4 hours, the model is predicting that his score is going to be 77. And the somebody who studies for 4 hours, his score is going to be 42. So this is what this model is predicting. It's actually taking this X test, is taking all these values, and is making a prediction on what the score is going to be. Now let's look at the actual score. So when I run this, and you can see this is the actual score. So model predicted 92 and the actual is 95. Not bad. The model predicted, let me just remove this cell. So it's you can see this. Okay, there you go. So the model predicted this one as 42 and the actual is 45. The model predicted 82 and 81. So that's, you can see that's pretty close. All right, let's see the performance metric of the model. So in this case, I'm using R square metrics. So I'm calling R2 function, and so there's a inbuilt method, there's an inbuilt function called r2 underscore score, and I'm feed my y test, which is the actual, the actual label or actual response for that data, and I'm also feeding the predicted value. So I run this, and that's going to give me my r square value. That comes out to be 0.9256. That's very good. So any number that's close to 1 is pretty good. So my model is doing pretty good in this instance.